Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this video lecture, let us see about Zener Diode and its characteristics. Zener Diode is one of the most important semiconductor diodes used in our daily life. It is a specific diode that works in the reverse bias condition. It allows current to flow from anode to cathode, and it also works in the reverse direction. It is a heavily doped PN junction diode that works in reverse bias conditions and is called as a Zener diode. They are special semiconductor devices that allow the current to flow in both forward and backward directions. For the Zener diode, the voltage drop across the diode is always constant irrespective of the applied voltage. Thus, Zener diodes are used as voltage regulators. Zener diode can be considered as a highly doped PN junction diode which is made such that it works in the reverse biased condition. It's also called as a breakdown diode. An electrical breakdown occurring in the reverse biased condition of the PN junction diode is called as the Zener Effect. So that breakdown voltage is known as the Zener voltage or the Zener voltage. So in this condition, when the electric field increases to a high value, it enables the tunneling of the electrons from the valence band to the conduction band of the semiconductor, which suddenly increases the reverse current. So this is the symbol of Zener diode. So as shown in the figure, the Zener diode has applications in various electronic devices and it works in reverse biasing condition. In reverse biasing, the P-type material of the diode is connected with the negative terminal of the power supply and the N-type material is connected with the positive terminal of the supply. So the diode consists of a very thin depletion region and it is made up of heavily doped semiconductor material. So it can be packed in many ways. Some Zener diodes are used where high levels of power dissipations are required. So Zener diode, which is the most commonly used, is contained within a small glass encapsulation having a band around one end and marking the cathode side of the diode. There are two tags at the end of the bar in the circuit symbol of the Zener diode. One in the upward direction and the other in the lower direction. So in this way we can easily distinguish between the Zener diode and other diodes. So high level impurities are added to a Zener diode to make it more conductive, and thus the Zener diodes can easily conduct electricity compared to other PN junction diodes. These impurities reduce the depletion layer of the Zener diode and make it very thin. Thus, this diode also works even if the voltage applied is very small. If no biasing conditions of the Zener diode, all the electrons accumulate in the valence band of the P-type semiconductor material and thus no current flow occurs through the diode. In reverse bias condition, if the Zener voltage is equal to the supplied voltage, the diode conducts electricity in the direction of reverse bias. When the Zener voltage equals the supplied voltage, the depletion layer vanishes completely. So this is a circuit diagram of the Zener diode. So it consists of a Zener diode and a resistor. So Zener diode provides the reference voltage, but the series resistor must be in place to limit the current into the diode. Otherwise, a large amount of current will flow through it and it would be destroyed. So the current is given by V1 minus V2 by R. So here the value of the resistor should be calculated to give the required value of the current for the supply voltage used. So next one, Zener diode, when it is used in the forward bias condition, it was working similar to that of the PN junction diode. So in the forward bias, the P type is connected to the positive terminal and the N type is connected to the negative terminal of the battery. So in this case, the electron and holes are swept across the junction and large current flows through it. So Zener diode in the reverse bias condition, as I said, the positive P type is connected to the negative terminal and the N type is connected to the positive terminal of the battery. So in the forward bias condition, the Zener diode works as a normal diode, but in the reverse biased condition, a small leak current flows through the diode. As we keep increasing the reverse voltage, it reaches a point where the reverse voltage equals the breakdown voltage. So the breakdown voltage is represented as Vz, and in this condition the current starts flowing in the diode. So after the breakdown voltage, the current increases drastically unit is reached a stable value. So in the reverse biased condition, two types of breakdown are there, which is avalanche breakdown and Zener breakdown. So here the figure shows the forward biased characteristics, which is similar to the PN junction diode. So this is the reverse biased condition. So here we have two types of breakdown, avalanche breakdown and Zener breakdown. So avalanche breakdown is a phenomenon of that occurs both in the ordinary diode and in Zener diode at high reverse voltage. For a high value of reverse voltage, the free electron in the PN junction diode gains energy and acquires high velocity, and these high velocity electrons collide with other atoms and knock electrons from that atoms. This collision continues and new electrons are available for conducting current, thus the current increases rapidly in the diode. This phenomenon of sudden increase in the current is called the avalanche breakdown. This phenomenon damages the diode permanently, whereas the Zener diode is a specific diode that is made to operate in the reverse voltage area. So in the reverse voltage is greater than 6 volts, the avalanche breakdown happens in the Zener diode. So this shows the reverse characteristics of the Zener diode. So once the breakdown voltage is reached, the current will start flowing as shown in the figure. So this is a forward and reverse biased condition. So next one is the Zener breakdown. So Zener breakdown happens in a heavily doped PN junction diode. In this diode, if the reverse bias voltage reach closer to the Zener voltage, the electric field gets stronger and is sufficient enough to pull the electrons from the valence band. These electrons then gain energy from the electric field and break free from the atom. Thus, for these diodes in the Zener breakdown region, a slight increase in the voltage causes a sudden increase in the current. So, as shown in the figure, so electrons are pulled out of their covalent bonds because of high intensity of the electric field. So, that case is known as the Zener breakdown. Next is few applications of Zener diodes. So Zener diodes are used as voltage regulators. So it's utilized as a shunt voltage controller for managing voltage across the little loads. The breakdown voltage of Zener diodes will be steady for a wide scope of current. So Zener diode is associated with corresponding to the heap to make its switch predisposition, and when the Zener diode surpasses the knee voltage, the voltage across the heap will become consistent. So it's also used in over voltage protection. So here when the uniform voltage is higher than the Zener breakdown voltage, the voltage across the resistor drops, bringing about a short out. This can be kept away from utilizing the Zener diode. It is also used in clipping circuits or limiter circuits and comparators, power supplies, etc. So hope you understood Zener diode clearly. So let us take up some assessment questions. So Zener diodes are also known as, the answer is breakdown diodes. So here, which of the following is true about the resistance of a Zener diode? So the options are: it has an incremental resistance, it has a dynamic resistance, the value of the resistance is the inverse of the slope of the VI characteristics of the Zener diode. So all these three are true. Which of the following can be used in series with the Zener diode so that the combination of the almost zero temperature coefficient? So the answer is diode. Thank you for watching this video.